Hi,
Hello, Shahebaz.
hi. Is it
Hi.
Priya?
Yeah, yeah, this
Yeah, yeah. Hi, Priya. So, I just need one thing.
Yeah.
Because I have two things to do today. One is present a PPT. Other one is project walkthrough. I want to do it with a different system. So, can I join? Uh, like in middle, I'm going to join and log in with other system while keeping this active. And basically, you have to give me permission to share the screen from other system so that
that Siddharth is taking care of. So yeah,
Okay.
he'll try to do that.
okay, sure. Basically this is I'm presenting this on a Mac because of video audio, and that is like a Linux based system, and I'm having Zoom issues with it.
Okay, no problem. Hello, everyone. Welcome to another session of the DataHour series. We'll just start in 5 more minutes. Till then, let's get to know each other. We have put up a poll that contains two questions about your location and experience level. Kindly answer the questions in the poll. Yeah, I'll be waiting for your response. Thank you. Kindly answer the question. Guys, kindly answer the questions in the poll. So guys, our next session would be on 8th of August. So you guys can just go and register yourself for that too. And please fill the poll. We'll be starting shortly. Yeah, so guys, we are just about to start the session for today. In the meanwhile, all those people who haven't filled the poll, they can do it.
I'm waiting for the sharing rights.
Okay, I'm.
Uh, were you able to transfer the rights, or you're starting BT
Yeah, I'm doing it. I'm doing it.
Okay, sure. You just like confirm when you're done, because like, yeah, I have no
Okay.
idea like, I got the access or when. Thanks.
Yeah, sure. Yeah, hi Shahebaz.
Hi.
Yeah,
Hi.
have you joined through the another system?
No, I'm going to do that in between slides, and I'm going to notify you when I do, but it will be the same email ID.
Okay. So we can start with the session, right?
Yep. Now we can start it.
Yeah. Okay. So, hi guys. Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Siddharth, part of the data science team at Analytics Vidhya, and I'll be the moderator for this session along with Priya. Yeah. So, for those who have joined us for the first time, a brief introduction to the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. That's why it's data hour. So we are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. So guys, now on to our session today, which is deploying deep learning model to production using FastAPI and Docker. So deploying a model to production is an art. From evaluating the right fitted model for the use case to choosing a model that has low latency, is reliable, and handles edge cases are all the decisions our data science expert makes. In this data, Mohammed Shahebaz will speak regarding best practices and have a walkthrough of deploying a deep learning model in production. I hope you are excited to attend this data with us. So guys, before we kick things off and I hand it over to our speaker, a quick recap of the housekeeping items. Like I would like to tell you some things, few points. So we are recording the session and we'll make the recording available in a few days on our YouTube channel. And guys, please use the Q&A section for asking any questions you might have during the session. And we'll do our best to answer them as the data progresses or towards the end. Also, we will share a poll about the feedback of the session towards the end of the session, which I request you all to kindly fill up. So now on to our speaker in this session of data. We have Mohammed Shahebaz with us. So guys, Shahebaz is a Kaggle Grandmaster and data scientist at DataRobot. He has experience building accurate value generating models that are scalable, creating an impact on millions of users with expertise in building state of the art models from the latest research, creative feature engineering, and building continuous training pipelines with live models, monitoring in production. So now over to you, Shahebaz. The virtual stage is all yours.
Hi, everybody. Is my audio clear and right?
Yeah.
Yep. Hi, everybody. Good evening. Thanks for joining in this session. Thanks for the intro. Yeah, I'm glad to be here. So today we are going to cover on how we go about deploying deep learning models using FastAPI and Docker. And before I dive into my session, I know you already have gotten my intro. So just a quick recap over that. So I currently work at DataRobot and I'm a Kaggle Grandmaster. But one thing that I can also add is I actually started my career and got break into data science with Analytics Vidhya. So I used to read the blogs, then I did internship over there. And that's how, my career progressed. I also did internship at H2O, worked for a couple of years in AI innovation with Society General as associate data scientist. And now I currently work with DataRobot, serving in America's professional services. So that's it about me. So today we are going to spend, this session in like two parts. I would divide. So in the first part, we'll be exploring, hey, what's AI, what it is to be called as like productionization, how do you go about it? And in the second half of the session, we are going through a project walkthrough. In the whole, the idea of this session was to compress the whole going about deployment in 1 hour. Although like deciding on deployment and all of this takes days and weeks sometimes, being able to decide. So this is going to be like a 101 session. And let me know if you're like interested in diving deep into some of these components. And you can also let our hosts know. They can like arrange DataHour sessions, prioritizing those topics. I just want to verify one quick thing. Okay, so let's talk about AI and where it is now today. So you can see AI be used as a recommendation. So any movies you see on Prime Video, Netflix, Hotstar, Disney, you got an AI behind it. You can see it in the photographic filters. You can also see AI being used in search. One of the recent feed by Google is like they have started incorporating percentile of few search results based on their latest and greatest bird technology. And they are also used by banks to detect fraud. You might have already known AI assistants like Alexa, Google Assistant, and Samsung Bixby. And all the way from translation to everyday lives, also in the scope of CCTV cameras, AI is going to be everywhere. And when I say about everywhere, it means that going forward in future, there can't be a tick, like it is called electricity of the future. So how electricity is like vital for any industry we can assume of, AI is also going to be part of our daily lives, and we cannot go around without encountering AI with us. So I have a quick video on Amazon Go. I hope you know this, but this is like introduction to future and one of the key intro that I can use and relate a lot of the concepts that I'm talking about. So I'm going ahead and playing, just starting 5 seconds of it. And I just want to confirm if you can hear the audio. If you can't, just confirm in the chat and we'll figure it out. Are you able to hear the audio?
4 years ago.
Yes.
Okay, that is great. Okay.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
I hope that was motivational enough, and that's the context I want to cover today. Is like, if you imagine a store that can do all of that, and imagine having all of our supermart stores with access to that technology, and that is what having AI in future is going to look like. Today we are seeing hey, kind of like translation or searches or like very little application, but when it is going to be implemented at the edge level and interacts with all other components that we have in our daily lives, it is going to be a transformative age to live in. And this is a study by McKinsey and Company that says that we know like today we are going to relate artificial intelligence with internet companies. Like, hey, you have an internet, you stream a video, or you talk about e-commerce. You think that AI only exists here, obviously, because these are the pioneer companies pushing the lengths and breadths of the AI. But the true impact by 2030, we can see the highest would be in terms of like retail. The video we just saw, like how easy it is going to be. And if you kind of like reflect and mirror that upon, let's say, healthcare system, let's say you were in emergency and you want to visit your loved one in a healthcare facility, you wouldn't have to waste any time at a cash counter or filling up financials, where everything will be taken care by AI, and you would just have to give your authentication per se. So this is a really trillion of US dollar technology. And today we are going to talk the very necessary things that you would be needing to be able to deploy this model. And when I say deploy, I do not mean like deploy one single model. If you have seen the video, you see there is a computer vision, there are sensors, there are like store detection, there is card detection. All of those technology augmented way are interacting and making that possible. So the very first thing that I would want to discuss, like what exists today, is the stack of ML and how enormously it has grown. So if you put together stack, let's say maybe for full stack backend, you would see same amount of libraries and offerings available. But in terms of like last decade alone, we have like explosive amount of libraries, ML technologies that you can use. Note that not all of them here are having the AI technology per se, because a lot of these are like databases, some are messaging queues, some are like IDEs, some are AutoML tools on top, and there are also libraries like TensorFlow and Keras. And in the world of libraries, one of the things that often confuse the young or like beginner data scientists is like, do I need to learn them all? Like, what do I need to learn is like often the most priority. And to sum that up, you do not need to learn all of the stack that is available out there, but only need to master either one or two of what is the basic requirement of the pipeline. I call it. So there is like data processing pipeline. So you can use SQL, Spark, but that are like one of few examples. In machine learning components, you might have already heard TensorFlow, Scikit-learn, Python, PyTorch. And there are also MLOps. DataRobot provides one, ML flows to deploy and monitor your applications. And what about scaling? So you need to be aware of like at least one of these components to be able to like deploy. Or if you are not thinking about scaling at 100 plus deployments for 100 million plus users, maybe step until 3 is like good fit for us. But the really crux of the part would be like scaling and deploy. Now, today, I know like this is like super huge, and hey, like how much time is it going to take to learn all of this? So it's like, I know like learning all of this is like a monumental kind of time you require. But today we will be covering, I'll be using these tools that you're seeing, like the tech stack of the project walkthrough we are going to have here. So we are going to use VS Code, the go-to IDE, I believe you're aware of, Scikit-learn, PyTorch, Swagger, Docker, Locus, and Transformers library from Hugging Face. So basically, all of these components like serve their individual purposes. So basically, would be for my logging. And when I talk about the stack per se here, you can always kind of like replace this with maybe basic vanilla logging in Python. But these are the stacks that I'm going to present today, not necessarily, these are like the always go to stack. Like your organization can have different needs. Let's say they are compliant only with TensorFlow, so you would switch to maybe TensorFlow based models. So the one thing before you decide the stack the one thing that sits common between all of these is like, how should you go about modeling? And either it is deep learning models and ML models, it is kind of the same. You would only have to account for the large size or maybe GPUs if you're having deep learning models out there. And basically, it all resolves to the machine learning design considerations. Now, we have seen in the retail video back that as soon as the user is going to pick up some products, the model is able to identify the correct user. It is able to relate it to the card that is dynamically being updated, and it is also charging. And let us assume that we are going into walking into the store, and once I pick up the product, it is not reflecting in my bill for first 10 seconds. I would be wondering that whether it has picked up, did it charge me extra bill because I have kept that product back and I do not want to get it. So the latency of the application is ultra low in this case. Like as soon as I pick up, I would want that to reflect in my card. And as soon as I drop it, it should minus from the said card. So really it comes to like consideration, like, hey, like what are the things that are important to you? And basically you need to understand how the model will be used. There are a couple of terminology that I'm going to talk in the next slide. The basic two terminologies that we sit upon is like latency and throughput. So basically it speaks about the time, how fast can you get my predictions? Let's say if you have a bandwidth of like, hey, it is okay if you return the predictions for 10 seconds because my applicant is like processing transaction. I can like give a initial confirmation, and after 10 seconds, I could predict if it is fraud and charge back my customer. That is a-okay case. In terms of like retail examples we have seen here, it would be less than 5 microseconds per se. So different applications have different latency, and that would completely change the approach or the way you think about the problem. And also the throughput. Let's say you have only one system, and particularly like, hey, it's like one engine, maybe query engine that doesn't get a lot of requests per se. Like I have only have couple of users who are like my expert users, and I want to charge this service as a premium. So not many users, like I do not have to cater hundreds and 10 millions of users per se. So you might make some validation and considerations there. But what if you want also the latency and the throughput? Like there are going to be at least 100 customers in the supermarket, and I want all the predictions to be in less than 4 microseconds. So something like that is called as throughput. And basically that is the main consideration you should go about. You are like, hey, what model should I choose? And we're going to talk about this. And this image credit goes to DALL-E. So basically the images that you have seen in the presentation are like cooked by that OpenAI model DALL-E. So this is like ant carrying a leaf, basically terminology to use and explain latency. So yeah, this is also done by deep learning model. So credits on the same. So when there are like different types of model consumptions. I was talking about like how the model is going to be used. So is it real time? Is it batch processed? Is it offline edge consumption? Maybe like you integrate a face detection technology in a drone, and that drone doesn't have to be connected to internet to be able to identify faces or objects. Or it can also be as a core component of your Android OS and iOS core ML. What that means is like you have something like a keyboard that predicts the next word that you're writing in. Now that keyboard is not necessarily making all the API class to predict your next word, because it is going to be super slow and totally inefficient. So Google and Apple have implemented their offline models in your mobile. They're also having special processor for it to have offline consumption of the ML model to do certain predictions like copy text from image, process your images, make them more beautiful. And there are some online edge consumption. Let's say you are, on a social media app like Instagram, TikTok, and you're using some creative filters that are sometimes extra funny, and note that that functionality is not available offline. So what happens is whenever you make a picture, click picture, it goes to server, it gets processed, it is sent to back, because mobile cannot handle that kind of processing, and that kind of it wouldn't be battery efficient per se. If I would put all of those gigabit models in your mobile, even if I make that 50 MB in size, your battery would drop off significantly, and the user would, at end of the month, would uninstall app, because this app is said like eating all of the battery. And I do not like this app because I want like all day battery life at least. So given like the topic of like latency and why does it matter, is because companies like Google and Booking like have proven with the results and A/B testing that if they reduce their accuracies, the search results drastically change and the conversion rate drops. And if you see, there was a CDN network, Akamai, which says that 100 microsecond delay can hurt a conversion rate of 7%. And when I talk about this conversion rate, it is usually linked to how ads and all CTR works, and how basically the money is credited to all of these like ad marketing companies. So 7% is a huge number there. And the last bullet point I want you to like critically think is like 53%. I mean, like if 100 users I have in the world, 53 users will drop if the page is taking more than 3 seconds to load. So that is kind of like real world, speed we work with. And if I input maybe something like recommender engine or something that takes 3-4 seconds itself to process prediction based off some deep learning model or machine learning model, then it is never going to see the light of the day, because the latency here is like just 3 seconds for the entire application. This is not for ML based, it is for the entire application. And the DevOps standards for 2015, when we talk about, were like, Etsy did 50 times deployments per day. Netflix used to modify or configure their production like 1,000 times a day. And AWS, every 11.7 seconds, there used to be some major update or something change in the production. That was in 2015. So imagine what is today at the scale of users and how much democratization we have in terms of apps and services we use. And the elite performers, nothing but a company or the developers, they are 973 times more frequent with around 6,000 times faster time to deploy versus the 2015 standards. So currently, imagine like this is already super impressive on a paper. And now we are like at today's scale, we are like 6,000 times more faster than what used to be in 2015. And this is majorly all the composition of like all the APIs per se, not only with respect to ML, but the crux that you should take it from here is how fast we are progressing in this industry. And going 5 years from now, we would be in position to have these constraints and deploy such large scale models. And the whole thing is like, how do you prove your model? Like, how do you make that model, the process? So this is like a bit of context so that we do not jump directly into modeling. And many of the attendees are sort of like confused. Hey, what are we talking today? Where is the model training and all of those happening? So this is the process, how the magic model that you're going to cook. So first you had to verify what kind of data, whether it's structured, unstructured, tables, images, text, whatever it can be. You have to collect the data, obviously clean, ensure the data is not biased. The step number 4 is extremely important. You had to commit the data version, like I'm going to use this for training, and I will always have this as my back reference on what kind of data my model was trained on. And you basically choose the metric and you derive the baseline. So all of this you do before even starting that model selection family or doing that dot fit process. So once you have all of this ready before training, only then you are set to like in the phase of like, hey, now I can go to the training phase. If any of this is not collected or done properly, it is going to severely affect how it scales. For an example, you do not know what kind of data you expect in prod, you get some different data, your API fails. You do not have enough data, your predictions are not going to be great. You do not clean your data enough, you would have bad analysis and numbers. You do not ensure there is a bias in your data, so you would discriminate some group or identity, and that can have negative PR effects. You have to choose a metric that would also optimize what organization cares about. For an example, all the social media company cares about average user time spent. And if your model is not improving that, you're not making people see more reels, stay or more engaged on the platform, it is not going to see the light of the day. And basically, how good is your model? Is it improving, or should I encode just random rules and not use machine learning at all? And during the training, you can see that you need to understand the model consumption. The first layer we were talking about, like, hey, how is the model going to be used? Offline, online, batch process. Like, should I process all the prediction and dump into some database and I will retrieve it later on? Or it is something like a Netflix that like I always refresh and recommendations are generated on the fly. I bet it doesn't happen that way because it is so inefficient. We are going to talk about that, how it is being optimized, but only on the high level today. And based on the latency, space, and throughput, how much faster you want, how big is your model? Like, let's say if my model is 5 gigabytes and I want to deploy it all over the world, let's say in Amazon Go case, imagine how much of size I would require if every model would be 5 GB. It would be impractical to scale unless I have some costs that are like, I put it in training server, but the ROI, like the amount of money the organization would make versus the cost of the deployment, if it doesn't match, it is not a good model because it is not doing its magic per se here. Then you train the model, you test score, you commit the model and data version. So the step number 6 is important because you would want to know which model was it and where did it come from which data version, so that when you train it in future, you would have the metrics to compare both the model and the data version. 7th is obviously deploy, monitor, and 9th is retrain and iteration unit. It can be minutes, days, or months. And mostly in my experience, I have also seen the model is trained every 10 minutes given on average per day. So every 10 minutes we spend, it is trained. And in the cases of maybe financial institutions, it can go as low as training for every 11 and 10 seconds because the stock market and all of those indices like do get changed and everything happens in seconds. So the model is going to be retrained for every 10 seconds. So before I started these slides and ended this, if there was like trading going on now here, maybe in the Eastern Standard Time Zone, we can already see like at least 1 million models retrained during this period that I'm presenting this slide. Now, the thing that you have to focus on, like once you have like shortlisted your approach and you would say that, hey, I'm going to deploy this model, how realistic is this going to be? So these are 5 constraints that you need to think about, is like the availability of your model. And not necessarily it is just the model, API in general, the whole end-to-end pipeline, right from feature engineering all the way to prediction and to giving that predictions. And reliability. Now, there is subtle difference between both of these. So availability speaks of like, hey, whether this is available and I can use this. And reliability is that, hey, at a time I try to send thousands of users to predict and I only get back responses for 80 users and 20 users requests or predictions are like dropped off. then that system is called not that reliable, but available. It is available. That's the reason we send the request, but it didn't return the said 100 by 100 users predictions back to me. So not reliable, but is available. Third is maintainable. So unlike software engineering life cycles, you can have like different time frames to like update your code base and all. Maybe you have a new product launch, but that is entirely different with machine learning, because you need to be so flexible that, hey, if I retrain a model, how quickly I can put this back to production with zero downtime. I cannot say something like, hey, the search engine will stop working for 5 minutes today, and because we are updating models somehow. So maintainability is like extremely important. Adaptability is also important. Let's say my neural network is not working, so I want to bring some transformer based model. Now, how quickly you can like upgrade these models from the old technology to new technology? If you would have to write the complete API or your whole design from scratch, it is not adaptable enough. Like you cannot make it better as the time goes. And obviously consistent. This is a bit unrelatable to in terms of like ML design, but I definitely know a case where this is a consideration, because not every ML use case you would use to fetch predictions. And I'm going to talk about this little bit later on to help you understand what consistency exactly is. But on a high level, it's just that instead of predicting every time, you also store kind of predictions. Let's say you are working on a search engine and there are some search terms and search results. You wouldn't want to invoke a deep learning model search results every time that particular term is searched upon. So let's say I search something like design considerations on Google. Every time I do not want to invoke BERT, because somebody would have already invoked it maybe in time frame of 6 months. I'll just return what was then, given that I have same model metrics and all of them are like constant. And if in every region people are trying to like see different results of your model, then like it is not consistent, at least in terms of performance. So examples of this can be like serve all predictions to EMEA regions, whether all the EMEA regions will be able to take my API. The latency should be 10 microseconds. It should be like 2 million predictions per second, and also easily maintain and update with low to no downtime and consistent performance and prediction. So, like with respect to deep learning, we can have different probabilities sometimes because of non-deterministic, but in the end, we would have to, accommodate something that like we are at least giving consistent results in terms of, our predictions. And coming to this entire model cycle, and what we are going to focus today is you do this data prep, you do training, and you do deploy. And these are the timeline and basically the model cycle. We have talked a bit of what training looks like in the previous slides. And the major part of today's we will cover is like the deploy part with the walkthrough code. And this will be the main concentration of today's topic on the project walkthrough. The other things I just want to touch upon is handling humility, in the sense like there was a incident with a huge real estate company where the model was not tested enough, and the house prices that was mentioned was way too low, and it caused lots of revenue loss for the company that it had to shut down its entire business segment. Now, handle humility rules suggest that, hey, if it is a regression model and I'm predicting sort of house prices, I can have on the region base, like no house can be less than, let's say, 2 lakhs. I could hand code that rule so that even if my model is predicting the house is for 5 rupees, it is not sold off at 5 rupees because of the modeling prediction error, maybe because of a drift, outlier, or things that are out of hand in production sometimes. We do not talk about today CPU versus GPU. It can be an entirely separate topic and optimization per se. We are not going to like project walkthrough on Kubernetes. optimization I'm going to touch upon, and ML ops also like is something like will be out of scope given we have limited time here. Going forward, so I want to introduce you to two main components that we'll be using today. So I just want to quickly pause here and make you understand what is FastAPI and why it is like important and monumental to what's happening in Python kind of APIs community. So before that, we used to use Flask, RESTful, Django, and all other frameworks. And what FastAPI has done to world of the ML tech stack is that it is very high performance and on par with what Node.js and Go offers. And it is one of the fastest Python frameworks available. If you're not aware, Python is kind of like a high level language that is like not as optimized as Java and C, and often it is not liked to be used in production because of the Python kind of overhead. And it was also like not easy to code ML kind of libraries out of this. So FastAPI is like not necessarily used for ML per se, but it is generally like a web framework to build APIs, and we have tailored it to use for machine learning operations. So it is easy, it is more robust, and it standardizes the open API specs, Swagger, and also takes care of the JSON schema. And if you see here various testimonies that we have on FastAPI, we have Microsoft team and data scientists and software engineers using FastAPI. We have Uber, Netflix, and in my personal capacity, I have used it abundantly both to deploy things for production and ad hoc data science predictions. All in all, this is like superb and great library. You need to learn this, and once you kind of like excel this, you're gonna do wonders. Now this is like bit preview time, what FastAPI really looks like. So this is my screen. So you can see that I have deployed it on Heroku. So I have a separate repo that I work on developing this API. So this is specially tailored for machine learning, ASAP modeling. So you can always go through. I have a couple of contributors, my friends who are working with me to make this more kind of like standard API kind of like template to work with. It is based on FastAPI. And as you can see that as soon as like I visit the website, it gives me a nice overt layer of different things like iris model that I can like use. I believe this is like SVM based model. So once this model is ready, I can use to perform predictions. And you can see all of this is like neatly documented in a Swagger UI where I have sepal, width, petal length, standard data science problem. And if you want to try out, you can click try out and maybe modify a few variables here. And you can execute, and this is going to return the predictions. In this case, it gives the prediction ID back and classify this point as Virginica. So let me also paste you the GitHub URL for the same. I'm going to give all of these resources. So basically, this is like a classification API you are seeing. The same can be done with regression here. So basically, go ahead. Note that this is like a try test. You wouldn't like really train model here. And this is not like a production terms of API. This is only to make sure all of my test passes so that when I go to production, I would have like clean code. And here you can see that I can also like do a linear regression model. I have all of these. And once I like execute this, I'm going to get the prediction ID and the price of the house in US dollar per se. And basically, this is how the FastAPI looks in the flesh. We are going to talk more about like, hey, and notice that this is for just like for machine learning models now, and I'm going to work on like a deep learning branch today here, which I already posted yesterday. So basically that would incorporate a deep learning model. And basically that's what we are going to dive in deep today. So before we get started diving in deep into the code, I want to quickly start an intro with Docker. And here I want to explain that Docker is kind of a technology that kind of democratizes, and it is because of Docker we are able to like scale and perform this, inferences with ultra low latencies, because irrespective of the host operating system, everything runs on top of that Docker. If you see app A, app B, app C, what we call is this having their own images and running. So aka what it means that irrespective you're on Windows, Linux, or any versions of Linux or this, your application will run without any errors. Now, this is very different what virtual machine is, because if you have something like a virtual machine, every time you kick off a virtual machine, you have to go install dependency, make that API up there, maybe write some code. Maybe that library is not available in Windows, it is not available in Linux. So you have to, go through all of the process. And also note that there can be different versions per se that can be different among, libraries that are like incompatible. So all of that is like taken care by Docker. If you are interested, I can also, you can search learning Docker, and there is a free code camp course in YouTube. And I think that should be the 101 thing that you should start if you're like interested in learning this. Now, I want to talk about the project Katana. Basically, this is the project I have been working on, and today we will be also showcasing how we go about modifying these projects and testing one of the deep learning models that I have. Just excuse me for a second because I'm going to join with my Linux system in the session, and yeah, then I'll be able to share the course. I'm loading up. Until then, I can maybe show you about the project we have here. So basically, you can git clone and get started here. Let me go to the most, cross-check branch here. So basically, all you need to do is, git clone this. You have a bunch of steps that you can use to, like install and set up this library. All of this is like documented well here. And in case you have any issues, you can like file PR here and issues, and will be on top of it. Just give a second. Joining it on my other system. Okay, I'm joining in. It's just loading. Okay.
Recording in progress.
I have host. Are you able to hear me?
Yeah.
Yep. Can you like share my screen? Hey, I'm back. Thank you so much. Okay, so we are back here. I have a lot of stuff to show you. So before we get started, I want to show you like, hey, this is how my projects look like and how this is structured. This is PPT. So yeah, hang on. So I have API session. I have a session on core, the logs, the script I use, the Docker component files, and the requirements that I run. Let me go ahead and share this project live with you. So basically, I'm using VS Code, and this is how I structured the code. All the core components of your AI and machine learning are always going to be in core, whether they are data sets, pipeline, or training some models. The API will handle things like, how the Boston prediction should look like, how the Iris prediction should look like. And the deep learning model we are working is like a masked model. So giving you a bit of overview, this model, what it does is that when I give a sentence, like, right, mask, am I good? So it is going to give me a word, maybe synonymously to, predict the fill in the blanks kind of scenario and see what machine learning model thinks. So the mask lang model, if you can go to core and trainer, you can, in pipeline, you can see that this is like a transformer based pipeline. I imported this pipeline. The model is distilled BERT and case. And basically how I structured this project is for every API that I would have an instance that train the model, and every instance would also handle the predictions. Note that if I have any pre-processing, that I do also before training, I should also include it in my prediction processing pipeline. And basically, the API also has like models that talks about, hey, for Iris model, what's the response we are expecting. And note that I'm not documenting all of these per se, like writing this in a documentation. I'm just using pydantic, and in this class, I'm declaring sepal length. It is kind of a float field with example value 12, and this is about sepal length in centimeters. And because I have declared all of this, you can see that in my local deployment here, all of those schemas are automatically recorded. And this is why I love FastAPI, because if you go something like a Boston request model, you can have everything documented for you, like crime rate by town, resident zone population. All of these is something that I have written in Boston House class here. And all of these are reflecting. So this will be like super easy if I want to hand over tasks, let's say, to my ML engineers. Mostly ML engineers would do this stuff, or anybody like ops team that would want to productionize this model. They have sort of all of these documentation available here. And if you're familiar with this terminology of like docs, this also supports like redoc, where it gives you a complete, UI on like documentation on what the different payloads and what they expect like. So both of this is available, but the default I route it to doc, so that, hey, it's very easy for me in terms of like machine learning model to test. So let me go to the code base and quickly show you how we go about deploying. Let me quit these instances. Make this small. So once I am here, all I would need to do is note that I'm already having my development branch. Because I have a Docker file written, and basically this is what Docker does. It goes to first this Docker compose, and any steps that I do in terms of like, hey, copy my model, copy my projects, run pip install, copy requirements, all of that is something that I have to declare in Docker file. So something like, hey, I need Python 3.8 because that's all my libraries depend on. So Python 3.8 is your work directory, requirements. Then I like pip install all of my requirements.txt. And if you see my requirements file here, it would have all the dependency that I care about. And this is as few as this. Like I do not have list of exploding requirements that you would require, to run or deploy some model. So basic FastAPI, Flake, Logguru for logging, scikit-learn to measure accuracy or train linear-based models, Ubicon, which basically hosts my API asynchronously, and transformers and PyTorch library. And the command that I need to run, this screen bigger, hope that is readable. So once I clear this, all I need to do is Docker compose up. And for the sake of the session, I'm building this again. So it like lays out this step. So what it does is like it already imported in Python 3.8 instance. It copied all of my code into a user source app library. It ran all of my requirements and it deployed my model. And you can see that it already fetches the data set, training my SVC classifier, which is support vector machine based. It is also training Boston-based linear regression model. And note that in the recent step, because I also included language mask model, it loaded my model, and right now it is downloading it from the hub. And once it is downloaded, and it will like warm load, and basically it will be ready for the deployment. So started the server process, waiting for application startup complete, and I have my API here, which is localhost 8000. So I go here, I refresh, my API is up and running, and note that this is very different from what I have online, which is already deployed. I do not have language mask model. So here, if I can go, I can see that, hey, this is basically a deep learning model, and the task I'm predicting is like, am I a dash person if I have save my green planet? So I'm expecting something like good, bad, some kind of like, AI model judging me for doing, saving my planet. How does it treat me? So when I execute, you can see that I have this payload where it says receive. Let me make this small. So receive payload as I am mask person if I save my green planet. Processing predictions and prediction process successfully. It gives me 200 response back, which I am here, and it gives me a score, a list of different words ordered by their probability of like priority. So if I say that I'm a mask person, if I save this planet, it says I'm a good person if I save my planet. I'm a better person. So AI thinks I'm better. So good. So let me try one more example sentence. Eating mask food is not healthy. So this particular API response, at least expect one mask. You can't have like two masks, because that's like basic assumption of the API and the model that we are running. So once we kind of execute it, you'll see the same processing pipeline. So it got a receipt of like eating mask, process successfully. Let's go back and say, and it says eating healthy food is not healthy. Something that machine doesn't make sense. So it got right in the third try, like eating animal food is not healthy, which is obviously, but do not trust any knowledge that this model is based upon. Basically, do not make it your teacher. So this model needs improvement, and I'm going to work on that, like how can make it better. So, but basically, this is how you go about, structuring your project, making few changes and deploying this out of Docker here. And I know this was like a fast run for this project, because this was more of like a walkthrough. One small thing that I would want to show you in terms of, hey, what I talked about, if I want to put this model to 100 million users, I wouldn't. If you can already see my predictions when I hit this execute, I'm already like 1, 2, 3, 4, 5 seconds apart, and anything is greater than that is like obviously not good for production. So obviously, like I cannot take this model. So what do I do with it? Basically, that talks about like optimizations on like how we should go about maybe deploying deep learning model if you want to use advanced offering capabilities. So there are a couple of things you can do is remember that this model is doing pre-processing and all of these things live, and that's basically causing the major delay in most of the cases. So what you can do is something we also do, kind of a data robot and also like an industry practice is like you can use maybe basic ML models on a neural network process vectors. So basically you use BERT to process all of your feature vectors, maybe train logistic regression on top of it, and it is faster, and we are going to see today. And there are other processes like distillation and quantization. Basically, it means third step means train a tiny mini model out of it. And the fourth step talks about, like instead of having float numbers in my model, I'll have maybe integer numbers. So step kind of 4 is mostly used in mobile-based applications because even distilled models are, too large enough to be deployed on our Android and iOS mobile phones. And the last thing I want to present today is the testing of this. So basically, I have also integrated a code that kind of like test only my ML models because we already know this particular DL model is, like for my computer, it is too heavy. Maybe if I have like higher infrastructure, it would give me low latency. That is right. This is second. So I can spawn something like 5 users and 10 users maybe, and 3 users start. And once I kick off this, it kind of tests my both Boston predict and Iris predict, and the whole code goes here. So I'm writing this test. I'm using locust. Remember, we talked about locust in our tech stack here. So I'm giving a random JSON response here. I'm always giving the same. In reality, I would have my unit test cases here. In Boston, also I'm doing, and you're seeing our APIs kind of taking loads of responses in here. And if you have seen, just in 10 seconds, 10,000 requests have finished. And this is the live chart you would synonymously see in production. How is your total requests per second doing? What is your average response time? And if you see here, we are already at 14, which is not good in terms of like functionality, because as I add more maybe power to my applications, it could be more stronger. So let's say that, hey, I will stop testing 2 APIs in one because my machine is just a laptop and it is not like a main server to experiment with. If I do this on AWS, it is going to be much faster. So in this case, I'm only testing the Iris prediction point. I'm not testing the other prediction point. And see, my API is not up. So okay, my API is up. So this is my API up all again. So I want to test it again, and I can this time give 10 users, both spawn at 3, but note that in my original testing file, and I'm only using Iris, meaning I'm only using like small ML model to see how it really performs on like real life scale. And you said like still I'm at 12, but it is going to like generalify. When I tested yesterday, it was giving about like 2 here. And maybe because I'm like Zoom sharing and all, like it doesn't have resources, so it's performing at like 14 here. So like stop this test, run this new test with only like 3 users and 1 spawn rate. Reset stats. You'll be seeing, hey, like my median response time is like less than 5. And this is something we would want in end of the day in real world production, to have synonymously. So if your APIs are like not scaling, not necessarily all of them should work 5 microseconds in a tiny laptop, but on the scale of the infrastructure we deal with, if you have something like 5 microseconds, it's like well and good, given it is like real-time prediction, not something like a batch type. But that would sum up what we are doing today. One other shout out I would like to give also to the project Katana is like, if you're interested in, you can always like reach out to me on the social media network or LinkedIn. And if you want to contribute this project, I'm more than happy to accommodate you. The code work we shown today is like still in deployment, and we're soon going to merge. And this is like AV DataHour commit on this. So this is, I know I passed the time, but this would be a quick Q&A session now.
Yeah, thanks a lot, Shahebaz.
Hi, yeah.
Yeah. So yeah, that was a great session, and I hope all our attendees found it really helpful. So guys, before we proceed to Q&A, I would like to request all the attendees to please fill in the poll about feedback, as it helps us to conduct more such sessions. I'm putting up the poll, please fill it. The poll is live, guys.
I'm answering some questions.
So, guys, you
So,
can ask your questions on Q&A section.
yeah. Is Katana currently open source? Yes, it is well open source. You can go to GitHub. You can, like, if you do not find this link, just search FastAPI and Katana. I think like you will find the URL and on the top search results. But basically, this is, yes, this is like open sourced. Do we need high GPUs and CPUs laptop? Tucker has asked to test the APIs. I think as minimal laptop as you need, but if you have something like a GPU specific application, you can do small testing on your laptop and GPUs, and then can do on large scale. But in no way you could test all that production grade APIs on your local laptop. This is like it just demo so that you can code up, and when you do deploy and higher infrastructure, it still works. So it is kind of end-to-end consolidation of sorts. Hope that helps. How do we decide on infrastructure to? So basically, what you need to know is like, will your organization is okay in supporting infrastructure, and how much? If they gave you some constraints like, hey, you will have 8 gigabits of RAM and maybe 3 instances of it, you need to make sure that your model is able to perform as expected in that optimization. But yeah, like you can do enough optimization, but not something like if you want to bring a huge deep learning model and altogether on a lower infrastructure, yeah, it is not possible. Tucker has asked for deployment. Yes, I have like used VS Code, and I think like it is very good. If like it is available in your organization to deploy, then yes, why not VS Code? FastAPI is different from REST API. So FastAPI is a library. REST API is kind of like a concept, but FastAPI is like sort of like making REST API faster in terms of like Python. So like conceptual wise, there is nothing called as FastAPI. It is just the name of a library. What architecture do you use to train model in 10 seconds? Because this is a demo project, in my project, if you're talking about, I only took the random data to train to show the API working. This is not for like real world predictions per se. In terms of model, the code and the whole Katana project is all about it. But I maybe a neural network or machine learning model, both of them would work. But something like a distill bird and like a low form, a model that is not greater than I would say 400 MB should do good. And if you have like awesome infrastructures, like 20 cluster of GPUs, then you can also use mega models like BERT to do things in 10 seconds. How do you ensure the data is not biased? So there are like a couple of things that you could do. Bias and fairness, but basically it resolves to EDA and analysis that, hey, if I have a categorical feature that has something like race, age, ethnicity, then I would want to make sure that the predictions that I get for these category are not bad. Something like, if I, let's say, belong from a particular country, I'm rejecting all the credit card application based on the feature country of origin, something like that. So that would be a signal that, hey, model is biased towards this region or country. But that's like basically high level of understanding bias and fairness. What data structure is better? I believe it would depend on the use case. So if you have something like a sparse matrix or something like vectorization, I also see KD trees being used, but most of the times it is tensors and matrices. Dict and all, I believe, is just to search the key value pair. But yeah, most of all it is like the matrices. Yep, you can always contribute to the project, Tushar. Thanks for your interest. Is Docker better than virtual machines? So both have their own pros and cons, but when I talk about like deployment and huge scale, Docker is better, but there are also some things with virtual machines, especially if your organization is like more compatible with those due to like constraints or maybe using a particular operating system. They can be a better choice, but there is nothing called as like this is always better than X. There is always an edge use cases where virtual machines can be a better choice for an organization versus Docker. Gradio and FastAPI. So what you can do is you can use both of them to do something like locus test and see how your application on like optimized codes perform, and basically it is up to the user selection and what stack they support, and you can do that stress testing on the API to see what works good, and yeah, that's how you resolve it. Tushar Goel asked, although I'm a beginner, like making simple projects. Yeah, that is great. Any suggestions on becoming Kaggle Grandmaster and what inspired you to build Katana? So yeah, I believe the only thing that you need is like go ahead, solve problems, choose something that always interests you at Kaggle, because if you choose a competition that let's say it is about making prediction for, let's say, financial services or helping some pets out for their adoption. If you're really curious about this problem and you really want to solve it, then Kaggle will look very easy compared to doing it just as a like project or task. So basically you do it dedicatedly and you would be a GM someday, hopefully. What inspired you to build Katana? So yeah, I was not liking that there was no enough like templates per se for machine learning. There are a lot of like full stack templates to build login screen, other things, but like ML specific, I didn't find any. And basically me and my other friends got together and created this. I think we have a couple of questions. We can maybe take over a chat and reply back to those. Yep.
Yeah, so thanks a lot, Shahebaz. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session.
Yeah, thank you. Just one small note. God.
Yeah.
So yeah, like if you have any follow-up questions and you want to reach out, you can always reach out to me like on LinkedIn. Obviously the host is going to help me with answering these questions, but apart from this, if you want to like brainstorm, connect, or talk about zombie or any alien inventions, which I'm very and super curious about, you can like always connect with me at LinkedIn. But yeah, this will be all. Thanks for having me, guys.
Yeah, thank you so much. Yeah, so I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. So guys, we are sharing Shahebaz's LinkedIn profile in the chat. You can just go and follow him over there. And I hope you guys have filled the feedback poll. So guys, the recording of this session will be available in a few days on our YouTube channel. So you can just go and follow the YouTube channel of Analytics Vidhya. And we will be back with another session of the Data Hour on 8th of August. The link is in the chat section. Till then, bye-bye and keep learning. So we'll meet next time. Thank you guys.